So as we conclude 1.7, now focusing where the composition of functions is. So this notation here can be a little intimidating because we have two functions for one thing. Normally we just have one, where one's a trinomial, one's a binomial, and they're asking us to evaluate f, what appears to be fog of x, which isn't just a new function. So what this O in the middle implies is a composition. So the composition is just a way for them to combine these functions, and it's different than just adding, subtracting, multiplying, or dividing. We're actually taking the one function and putting it into the other one. This is similar to the beginning when I said this is like Inception. This is where there's kind of a dream within a dream within a dream, or similar to the one toy I talked about where it's kind of an egg and an egg and an egg. Let's make this one happy. Let's make this one sad. Let's make this one barely there. So it's as if we're taking one of these equations and putting it into the other. And so I think rewriting this might make your life a little bit easier. So this is one way that they might interpret a composition of functions. The way that I'm writing here is also fair game, and I think this is the easiest one to consider. And these are equivalent forms. So if we look closely at this, we would say that this is f of g of x. So the input for f is g of x. Well, we know that g of x is 2 minus x, so let's see if we can try to rewrite this further. These are equivalent. Hopefully this clears the air a little bit. So at the beginning, it gave us f of x, which was negative x squared plus 3x minus 4, which is totally fine. But now they're saying that instead of x, they want 2 minus x. And this example in particular is going to get a little scary because we have to FOIL. We also have to combine like terms and keep in mind that there's a negative sign there. So we'll take this one step at a time. So if I rewrite f of x, I know that that's negative x squared plus 3x minus 4. If I'm now writing in 2 minus x, this is still subtracting. Instead of x, I now want 2 minus x. So now that's being squared, and I'm using parentheses because I want to keep that separate. We're then adding on 3 versions of 2 minus x. And then we're subtracting 4. Take a moment, take a breather, double check this, make sure it looks good. Of course, if you have questions as to how this looks, you can always ask in class. But with this one, trust me on this one, this is how it should look. So now from here, it's a matter of combining. First, I would approach with the exponent. So go with order of operations. There's nothing really to combine in parentheses, so the exponents should be combined. So here, it's as if we're evaluating 2 minus x squared first. Kind of an odd binomial, but if we FOIL this out, you could consider this 4 minus 2x, and adding on x squared. If you're not convinced, use box method, FOIL it, do what you need to do. So I'm going to rewrite this now as still subtracting, but now 4 minus 2x plus x squared. I'll start to distribute in this 3, so plus 6 minus 3x minus 4. Keeping in mind that we're subtracting all of this all of this trinomial. That's really crucial. Hold on to any sign that's given to you in the equation because you need it. So if we start to distribute that in, it's as if we're subtracting it. So you could write in subtracting 4, adding on 2x, subtracting x squared, plus 6 minus 3x minus 4. From here, it's just combining like terms. So I know I have negative x squared on its own. see an x term here, 2x, negative 3x. 2x minus 3x gets us negative x. And then finally, with our constants, we have negative 4, adding 6, deducting 4. So think of that as negative 4 plus 6, which is 2. 2 minus 4 is negative 2. Sometimes they'll just interpret this as f of g using this notation here. This one also asked us for the domain. Since this is just a parabola, domain for this one's going to be all real. If you're not convinced, we can graph this out, but I'm confident the domain for this is all real. For the second part, this has us taking a little bit of a different approach. So we're now taking a composition and then finding what values of x are going to have this all equal to negative 4. So this is different than before. We're kind of working backwards, but I'll do my best to try and rewrite this. So we have these two different functions. They're asking us to find values of x. So eventually we want our answer to say x equals these numbers that satisfy this composition of f and g, and it all equals negative 4. So if I rewrite this, f of g of x equals negative 4. I think this is a good starting point if you get stuck with these types of problems, because at least you can visualize what's going where. So you know that g of x is x squared minus 2x plus 5. You know that f of x is normally 4 minus x. So you can now rewrite this as just 4, and instead of x, we want to subtract this trinomial here, x squared minus 2x plus 5. We take this further, 4, subtracting x squared, adding 2x, subtracting 5. I'm going to star this in red because this is where I see students trip up a bit, is subtracting the entire trinomial. You might just think, oh, well, it just distributes to 1 and I'm done. Think of it as its entire, like an entire thing. You need to distribute everywhere. So if we combine from here, we have 4, negative 5. We can take that further. We have 4 minus 5. We can think of that as negative 1. And we're still trying to solve for where all of this equals negative 4, because that was given to us at the beginning of the problem. So that's still our objective. Since we're dealing with an x squared term and we already have a trinomial here, this looks as if it's tricky and there's not much you can do, but we can luckily solve this if we factor. And it seems odd because if we move 4 over here, that will get us in the right direction, but not quite where we want to be. So I think the best option is to move all of these terms to the right, because x squared will change and we'll have all of our terms on the same side, which is good because then we can factor. So if we move so we're moving all of these terms to the right. When we do that, we end up with x squared, now positive. What was originally positive 2x is now negative 2x, because we're using opposites to move it over. We had a negative 1, but now we're adding that. We also have negative 4, and now this all equals 0. So this should kind of look like an algebra 2 problem. If we combine from here, x squared minus 2x minus 3, this still equals 0. Students that I have for Algebra 2, this should look like something you can definitely factor and solve. So we have a product of negative 3, sum of negative 2. The only two numbers that are going to work here are negative 3 and 1. So when factor, this is going to be x minus 3, x plus 1, This all equals 0. Eventually, when we solve for these roots, the only numbers that make sense are going to be when x is 3 and when x is negative 1. So that's our final answer here. The values that make sense are going to be 3 or negative 1. We don't want to say 3 and 1 because then that's implying 3 equals negative 1 and then math explodes. So we don't want to say that. If you're not convinced that this works, if you want to go off of the visual, I'm just going to graph out this trinomial here. So we get rid of everything. We have x and we're squaring that. We're then deducting 2x. We're subtracting 3. We were trying to see where the outcome is 0 because we shifted some terms around to get that. So we see that one answer is negative 1. We also see that if x is 3, the outcome is 0. So these two answers are fair game because logically, when plugged back in, it makes sense. So lots going on with these two problems, but take your time.